Right now, in a kitchen somewhere near you, someone is about to get attacked by a common, unassuming vegetable. They have no idea that they are about to trigger a sophisticated chemical defense system hidden within the onion. For over 5,000 years, every major civilization that touched this plant got the underlying science completely and utterly wrong. The ancient Egyptians worshipped it, believing its layered rings symbolized eternal life, yet they remained blind to its true nature. The Romans, in a bizarre twist of history, actually classified the onion as a fruit, lumping it in with apples. Greek athletes even rubbed onion juice on their skin before competing, mistakenly believing it could somehow enrich their own blood. Despite its status as a culinary staple in kitchens worldwide, the true mechanism behind its power remained a total mystery. Not one person, across 5 millennia of human history, truly understood what was happening at the molecular level inside. It was not until 2002 that 2 dedicated scientists in Japan finally cracked the code and opened the case file. What they discovered was not just a single chemical reaction, but 2 distinct processes stacked right on top of each other. This hidden sequence was something nobody had even thought to look for, despite centuries of human interaction with onions. By the end of this, you will understand exactly what is happening inside your own eye, down to the second. The problem is that you have probably cut hundreds of onions in your life, assuming you understood why you cried. The reality is that almost nobody, including the greatest scientific minds of the past, ever truly understood the process. But here is the secret almost nobody knows about this weapon sitting in your kitchen. It is a double reaction. To understand it, we have to look inside an undamaged onion cell, where everything is kept in perfect, safe isolation. There, a compound called S1-propanol, L, cysteine sulfoxide is sealed away inside the cell's tiny, protective vacuole. Separately, in its own distinct compartment, sits an enzyme called a lionase, waiting for a signal to begin its work. As long as you keep these 2 components apart, nothing happens. The onion remains perfectly stable and harmless to you. But the second your knife breaks through that cell wall, those compartments rupture, and the 2 chemicals collide instantly. The lionase immediately goes to work on the sulfoxide, and out comes an unstable byproduct called 1-propansulfenic acid. For decades, scientists used to think that was the final step, believing the case was closed and the mystery solved. They were wrong, and in 2002, researchers Imai and his team blew that long-standing theory wide open for everyone. They discovered a second enzyme, one that nobody had ever detected before, hiding in plain sight within the onion cells. It is called lacrimatory factor synthase, and it is the missing piece of the puzzle that changed everything we knew. This enzyme grabs that unstable sulfenic acid and rearranges it into the actual molecule responsible for your tears. That molecule is syn-propanethyl S-oxide, a potent compound that serves as the onion's primary chemical defense mechanism. Let that sink in for a moment. For decades, scientists blamed the wrong enzyme, while the real culprit sat undetected. That gas is incredibly light enough to drift straight up toward your eyes the instant your knife touches it. So, what actually happens when that gas finally reaches you and makes contact with your delicate, watery eye surface? The syn-propanethyl S-oxide hits the tear film on your eye, reacting to form trace amounts of sulfuric acid and sulfide. These are tiny amounts, certainly, but they are more than enough to trigger a powerful response from your body. Those compounds immediately fire up your trigeminal nerve, the same nerve responsible for facial sensation and corneal sensitivity. Here's the twist most people miss. Your brain does not process this as an onion, but as a threat. It reads the chemical presence as a direct attack, prompting your lacrimal glands to flood the eye with tears. It is a reflex that takes only a fraction of a second, designed to dilute the threat and flush it out. Now that we understand the mechanism, the various kitchen hacks and fixes finally start to make some logical sense. Chilling the onion works because cold slows down enzyme kinetics, meaning both enzymes move slower and produce less gas. Cutting near airflow also works, as the gas is airborne and moving air disperses it before it hits your eyes. A sharper knife is also legitimate, as fewer ruptured cells per cut means less sulfenic acid is produced initially. However, tricks like putting a spoon in your mouth or lighting a candle nearby have no backing in chemistry. We went looking for a real mechanism behind those popular myths, but we found absolutely nothing to support them. But here is the payoff, the part that makes this whole investigation worth the effort for any home cook. The same sulfur pathway responsible for your tears is also tied to several of the onion's most studied health benefits. Research has linked these organosulfur compounds to antioxidant activity and even significant anti-inflammatory effects in the human body. Then, you apply heat, And everything changes because cooking destroys both of the enzymes involved in the reaction. This is exactly why a cooked onion never makes you cry, regardless of how many you chop up for dinner. Heat kicks off a totally different process known as the Maillard reaction, the same one behind a seared steak. It transforms those sharp sulfur compounds into something else entirely, that deep, sweet, caramelized flavor we all love. One molecule, two enzymes, and two completely different identities, all depending on the temperature of your cooking surface. It is either a weapon to defend the plant, or a flavor to delight the palate, depending on your actions. So, let us close the case, having finally understood the complex chemistry that has been happening all along. An onion stores a sulfoxide and an enzyme separately for self-defense, and you trigger the reaction by cutting it. That two-step reaction fires off in a way that nobody fully understood until the breakthrough research of 2002. Your trigeminal nerve picks up the threat, and your lacrimal glands respond exactly the way they were built to. 3 major civilizations worshipped this thing and feared it, yet they were completely and utterly wrong about it. It took modern chemistry less than 30 years to explain what evolution had perfected over thousands of years. Next time you cut into one, you will not just see a vegetable, but a 5,000-year-old chemical defense system. If an onion has been hiding 2 enzymes and a weapon this whole time, what else is in your kitchen? There are surely other secrets waiting to be discovered, and that is exactly where we are going next. For over 5,000 years, civilizations from Egypt to Rome were completely baffled by the onion's strange, tear-inducing power. Ancient Egyptians revered the onion as a symbol of eternal life, while Roman soldiers believed it granted them immense battlefield strength. Even more bizarrely, the Romans classified the humble onion as a fruit, placing it in the same category as sweet apples. Greek athletes would rub onion juice onto their skin before competing, convinced it could somehow enrich their blood and improve performance. Despite these elaborate cultural myths, not a single civilization understood the actual chemical reality hidden inside the onion's layered structure. For 5 millennia, humanity remained in the dark, unaware that a sophisticated chemical weapon was sitting in their kitchens all along. The mystery finally began to unravel in 2002, when 2 Japanese researchers, Imai and his team, decided to look deeper. They discovered that the onion's defense mechanism wasn't just one chemical reaction, but 2 distinct steps stacked on top of each other. Inside an undamaged onion cell, a compound called S1-propanol L-cysteine sulfoxide sits safely tucked away inside the cell's vacuole. Separated from this compound in its own compartment is an enzyme known as alliinase, waiting for a moment of disturbance. As long as these 2 components remain isolated, the onion is perfectly stable and completely harmless to anyone standing nearby. But the moment your knife blade slices through the cell wall, those internal compartments rupture and the chemicals collide instantly. The alliinase enzyme immediately goes to work on the sulfoxide, producing an unstable byproduct called 1-propansulfenic acid. For decades, scientists mistakenly believed this was the final step of the process, but the true culprit remained hidden. Imai and his team blew that theory wide open by identifying a second, previously undetected enzyme, lacrimatory factor synthase. This second enzyme acts as the final architect, grabbing the unstable sulfenic acid and rearranging it into a new molecule. The resulting compound is syn-propanethyl S-oxide, the actual molecule responsible for your tears, which was hiding in plain sight. This gas is incredibly light, allowing it to drift upward toward your eyes the very instant your knife touches the onion. When the gas reaches your eye, it hits the watery tear film on the surface and reacts to form trace amounts of sulfuric acid. These tiny amounts of acid immediately fire up your trigeminal nerve, which is wired directly into your sensitive cornea. Your brain does not interpret this as a vegetable, but rather as a direct chemical threat to your vision. In a fraction of a second, your lacrimal glands flood the eye with tears, a reflex designed to dilute and flush out the acid. With this mechanism finally understood, we can separate the effective kitchen hacks from the ones that are purely based on myth. Chilling the onion is scientifically sound, as lower temperatures slow down enzyme kinetics, meaning less gas is produced during cutting. Cutting the onion near a strong airflow is also effective, as it disperses the volatile gas before it can reach your eyes. Using a razor-sharp knife is another legitimate tactic, as it ruptures fewer cells and limits the initial release of sulfenic acid. However, common tricks like holding a spoon in your mouth or lighting a candle nearby have no chemical basis whatsoever. We have searched for a mechanism behind those myths, but found nothing that could actually stop the gas from reaching your nerves. The payoff for this scientific investigation is discovering that the same sulfur pathway is tied to the onion's health benefits. Research has linked these organosulfur compounds to antioxidant activity and even anti-inflammatory effects within the human body. When you apply heat, the outcome changes completely. The high temperature destroys these enzymes, preventing the gas from forming. This heat-driven process enables the Maillard reaction, the same browning process that gives a seared steak its deep, savory flavor. It transforms those sharp, pungent sulfur compounds into the rich, sweet, and caramelized notes we love in cooked dishes. One molecule, two enzymes, and two completely different identities. The onion is either a chemical weapon or a flavor powerhouse. Ultimately, the onion is a sophisticated 5,000-year-old defense system, reminding us that even common items harbor complex secrets. It took modern chemistry less than 30 years to explain what evolution had already perfected over thousands of years of survival. Next time you cut into an onion, you will see more than just a vegetable. You will see an ancient defense system. It is a system completing its mission right there on your cutting board, just as it has for countless generations. If a simple vegetable has been hiding two enzymes and a chemical weapon, imagine what else is sitting in your kitchen. There are countless everyday objects that nobody has bothered to look at closely, and that is exactly where we are going next. We have only scratched the surface of the hidden chemistry that dictates our daily lives and our culinary experiences. The story of the onion is a testament to how science can turn a simple annoyance into a fascinating lesson in biology. Every tear shed in the kitchen is a reminder of the complex, invisible battles occurring at the molecular level. By understanding these processes, we gain more than just better cooking techniques. We gain a deeper appreciation for nature's design. The onion's journey from a worshipped relic to a scientific case study shows how far our understanding has truly come. We no longer need to rely on myths or ancient superstitions to explain the world around us and the food we eat. Chemistry provides the clarity needed to navigate our kitchens with confidence, precision, and a bit of scientific curiosity. So, keep your knives sharp, your onions chilled, and your mind open to the hidden wonders of the culinary world. There's always more to learn, more to discover, and more to explain about the things we take for granted. The next time you find yourself crying over an onion, remember the two enzymes and the 5,000 years of mystery. It is a small price to pay for the incredible depth of flavor that this remarkable plant brings to our tables. We have successfully closed the case on the onion, but the kitchen remains a laboratory full of unsolved puzzles. From the way bread rises to the way coffee beans roast, every ingredient has a story waiting to be told. We will continue to peel back the layers, just like we did with the onion, to find the truth underneath. Stay tuned as we investigate the next common household item that holds a secret, complex, and fascinating chemical history. The world is full of hidden mechanisms, and we are just getting started on our journey to uncover them all. Thank you for joining us on this deep dive into the molecular defense system of one of nature's most resilient plants. Keep questioning, keep exploring, and never stop looking for the science hidden in the most unexpected of places. The kitchen is not just a place to cook. It is a place to learn, experiment, and marvel at the world. We look forward to seeing you in the next episode as we continue our quest to explain the world's hidden mysteries.